Hi everyone, my name is Peter. Welcome to my YouTube tutorial. In this section, we are continuing with the reactions of alcohols, and in this chapter, we are going to discuss the elimination reactions. And under this, we shall do the dehydration of an alcohol. So basically, the word dehydration means D means to remove, hydration means water. So we are forming water and some other compound. So alcohols undergo dehydration when we react them with a concentrated sulfuric acid in presence of heat. Then we form an alkene and water as our product. So therefore, with this reaction, we shall say that it is also classified under with E1 and E2, whereby E1 involves a secondary and tertiary alcohols, and E2 is specifically for primary alcohols. So in E2, we do not form what we call carbocations. So basically, that's why because primary alcohols can form stable carbocations. So therefore, let us jump in the mechanism of action of how we form this. So therefore, remember sulfuric acid acts as a catalyst in this reaction. So we shall have remember that this anion is partially positive and hydrogen is partially hydrogen partially positive, and this sulfonate ion is partially negative. So therefore, this oxygen lone pairs of electron will attack this hydrogen, and this bond breaks off. Then we form something like this. So the oxygen gets a positive, and this hydrogen sulfate ion comes back. So it's going to take its proton. So when this hydrogen is taken, this bond shifts and forms a double bond between these two carbons. So that rearranges this water molecule, breaks off, and our final product will be this and that. So this is the general mechanism in elimination of dehydration of alcohols under E2, elimination E2. So primary alcohols react to form alkenes, to form this type of alkenes. So we shall see that also this type of elimination is stereosensitive. So we shall be dealing more with the trans and cis isomers and see how they come into play when we do this. So let us try to do an example with a secondary alcohol such as CH3. So the mechanism is still the same. This lone pair of electrons attack this hydrogen, this bond breaks off, then we form a CH3, CH, OH2, CH3 plus the SHO4 minus. So now, at this point, this is when we decide. So if this sulfonate ion, hydrogen sulfonate ions attacks this hydrogen, so this bond shifts here, and then this water molecule breaks off as a result, and then our final product will be a CH double bond CH to CH3, which is propene. So now this is our final product. Propene is our final product from this. So this we know that secondary alcohols can have this type of mechanism, can either undergo with E2 or E1. So this is how secondary alcohol can react with an E2 type of mechanism. So in E1, so this is where they would differ from. So in E1, what will happen is this water molecule breaks off before this hydrogen is taken away by the hydrogen sulfate. So when the water molecule is lost, then we shall form the carbocation on this carbon. So when the hydrogen sulfate comes in, it attacks this hydrogen, this bond shifts here, then we form the final product. So basically this is how secondary alcohols can react. They can undergo with E2 or E1 because they can form a stabler carbocation than primary alcohols. So now lastly, let us look at tertiary alcohol. The tertiary alcohol and see how it reacts. So a tertiary alcohol so if I have this type of tertiary alcohol and I react it with a sulfuric acid, so the oxygen will attack the hydrogen, this bond breaks off in favor of the molecule, then we shall form something like this. So now this bond can break off because this tertiary alcohol can form a stable carbocation. So we shall form our final product as CH3, C to the double bond, CH3 to the C to the CH3 and CH3. So this forms this stable carbocation. So now from this we can have two products from this compound. So we can have CH3 carbon double bond to the CH3 to the C, CH3 and the CH3. Actually it's one compound that we shall have this type of molecule. So this is our final product with this type of alcohol. So we shall see in other types of mechanisms where we have what we call hydride or methyl shifts. So if I have a structure like this, so if I have a structure like this and I want to find the final product, so what I will do, so this will attack this carbon, that bond breaks off, then I'll have this protonated alcohol and these two methyl groups. So now when this bond breaks off in favor of oxygen to form water, I will remain with this compound So remember, I have if I pull a hydrogen from this, I'll form a double bond here. So that's one of my my steps that I can take. So if I boil this hydrogen to form a double bond, so remember this hydrogen will be taken up by this base, then I form a double bond there. Then my first product will be this. Then my other alternative will be I can have what we call a 1,2 methyl shift. So one of these methyl group can shift from here to this position. So I can do that, and I say 1, 2 methyl shift. Then my final product will be so remember I've shifted this methyl group from here to here, so now the carbocation will shift to that atom. So now you see that this carbocation is having 1, 2, 3 carbon atoms surrounding it, so it is more stable because it has 3 methyl groups surrounding it. Whereas in the first one, this carbocation has only 1, 2. So this is more stable than this. So the hydrogen from this carbon will be taken up by the hydrogen sulfate, and a double bond will be formed here. So then our final product will be this is the final major product. This is a minor product. This is our major product. Because of this 1,2 methyl shift, this carbocation is more stable than this carbocation. So therefore, most of the products we shall form will be that product, but not this product. So there are so many questions as far as hydrogen or 1,2 methyl shift is concerned. So therefore, you will meet many of them, and this is basically the mechanism. It's all about seeing which type of carbocation is more stable than the other. That will lead to formation of the major product. So basically, that's it for elimination 1 and 2 or dehydration of alcohols. Thank you very much for watching. See you in my next tutorials. Bye for now.